Warning: the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This lecture begins a series of review for trigonometry for a pre-calculus student. It is assumed that you have had a full course in trigonometry, so this is only going to be a quick high-level review just to remind you of some of the language that we use in trigonometry and some of the important details of trigonometry. But I will say, if you have not had a full course in trigonometry, you will need to actually either take in a full entire course of trig or watch a whole series of videos for trigonometry, which I am currently recording for my trigonometry course. So it is just that important to note. If you're in a pre-calculus class, you need a full semester's course of trigonometry already under your belt. All right, as a review, in the text I use, we'll focus initially on the unit circle approach to trigonometry. There are, as you know, two approaches, one being unit circle approach and one being the right triangle approach. My preferred approach is the right triangle approach. However, the unit circle has some merits, especially in calculus, because you're going to learn of a new type of function in calculus called a hyperbolic function, which is not a circular function, where our current trigonometric functions are circular functions because they're based on the unit circle. So having that knowledge of the unit circle definition of a trigonometric function is very important. So let's just remind ourselves of the unit circle. That's what this whole video here is all about. What is the unit circle? Well, the unit circle is the circle of radius 1 centered at the origin in the xy plane. So if I were to draw out the xy plane here, the unit circle would just be the circle of radius 1. And I'm not really drawing a great circle. I apologize. I'm sure that I have some type of app that allows me to draw a beautiful circle, but I just didn't use it. So there we go. It goes through the point 1, 0 and 0, 1 and -1, 0 and so on and so forth. Its equation is given by, according to this theorem, x squared plus y squared is equal to 1. And you know that just from your previous work through algebra. Remember, the equation of a circle in algebra is x minus h and quantity squared plus y minus k and quantity squared is equal to r squared, where h and k are the center of the circle, and our unit circle has center at the origin, so they're both 0 in this case, and r is the radius of the circle. Well, the unit circle has radius 1, so therefore you get x squared plus y squared is equal to 1. That's the equation of the unit circle. Just a quick reminder, right? So let's go ahead and take an example here. The point x, 2/3 lies on the unit circle in quadrant 3. Let's go ahead and find the value of x. There's a lot of different ways this question could be asked. And as you move forward in mathematics, specifically when you step into calculus, the questions become more outside of the realm of what you're taught within the class. Within the class, you're taught mechanics, but then as you approach the homework, there are just some obscure references to the mechanics that you're making or that you're using. And the questions become more robust. It requires a lot more synthesis of information. Notice in this question, I need to understand what a point is. Obviously we do. I need to understand what a unit circle is. Obviously we do. You have to understand where quadrant 3 is. You should. And you should know that this is implying that you're going to be using the equation of the unit circle and this point on it to find out what x is. So the unit circle has the equation x squared plus y squared. In this case, our y value is given to us to be 2/3 is equal to 1. So you can see we can easily solve for x here. This implies x squared plus 4/9 is equal to 1, or in other words, x squared is equal to 5/9. Take the square root of both sides, and you should know that when you take the square root of x squared, it gets back an absolute value of x, and the absolute value is either x or negative x, just depending upon whether x was positive or negative to begin with. And so a lot of us see this as plus or minus x. You probably have seen it written that way many a time. And so x will be plus or minus the square root of 5/3. Now remember, our restraint here, or our constraint, I should say, is that this point is on the unit circle and it's in quadrant 3. Well, in quadrant 3, which is this quadrant right here, all the x values should be negative. Oh, that point can't be in quadrant 3. It should have been a negative 2/3. Sorry about that. It's my fault. I will actually fix my lecture notes accordingly right now, but I mainly just kind of wrote this down very quickly just to get it going. So that point should have been a negative 2/3 because the y value in quadrant 3 is also negative. I apologize. It doesn't really change anything else though, because when you square a negative 2/3, it becomes 4/9. So we're still okay. But note the x values here in quadrant 3 are negative as well. So of the two options for this x, we will choose the negative option because again, that point is in quadrant 3. So the actual point will be negative root 5/3, comma, negative 2/3, because that negative y value that I forgot to write in there. Sorry about that. And now we get to a definition that is critically important for us to understand, the terminal point. So the point P of xy, or P, which is x comma y, located a distance of t measured counterclockwise along the circumference of the unit circle from the point 1, 0 is called a terminal point determined by t. This is core to the unit circle definition, and a picture is worth 1,000 words. So let's go ahead and throw a picture on here. Notice that this is a very large circle. I just wanted to be kind of complete here. And so we're going to plot a point on there. I'll just plot a point. Maybe I'll do it way over here, right there. And I'll label that point also in red, P of, not of, but P, which is x comma y. That's the point. And then we have a distance, just based on this definition, we have a distance measured counterclockwise along the circumference from the point 1, 0. And the point 1, 0, let me plot that right over here. That's the point 1, 0 right there, 1, 0. And so we want an arc length from that point counterclockwise to the point P. So let me get that going here. This distance right here is what we would call an arc length. And we're going to label that distance T. So P, which is the point x comma y, is the terminal point determined by T, because T is just a length along the circumference of this circle, and it ends or terminates at the point P, and that's why we'd call P the terminal point determined by T. It should be noted that terminal points can be negative, or in other words, T can be negative. The fact that T is positive here is given from the fact that we define counterclockwise motion as being positive. So when you have your arc drawing out this direction, that's called the positive direction. That is more of a just an agreed upon rule that we just say counterclockwise is a positive direction. Now T could be negative, so let's pretend as though we have a point right here. Let's go ahead and call that point Q. It also has an X and a Y value, obviously. Well, if you carve out an arc in the clockwise direction, just like this, that will be a length, T, but it will be negative because clockwise rotations are considered negative in trigonometry, as you know from your prerequisite trigonometry course. Now, if you don't recall learning trigonometry using the unit circle, you're not really going to be totally hurt. In fact, I prefer to do all of my trigonometry using right triangle trig, so it's not going to kill you to not know 100% the unit circle. It's just that people talk about the unit circle quite a bit, so you do need to be able to engage in those conversations. The unit circle is really based upon the unit circle definition of trigonometry, that is. It's based upon these arc lengths. So this distance in orange here, that is a distance of t. And something, by the way, we should know or recall is that we can actually compute the total distance around this circle. This total distance all the way around it should be easy to recall. And that's where our next theorem is. The total distance around the unit circle is 2 pi. Well, why? Because the distance around a circle is called the circumference, which is kind of an interesting little note here. The distance is called the circumference. Also, if you just kind of run around the edge of the circle, we're saying you're running around the circumference of the circle. So not only is it a measured distance, but it's also considered to be the edge of the circle. Anyhow, and we know from pre-algebra or arithmetic courses that the circumference is equal to 2 pi r, but on a unit circle, r is equal to 1. And so the total circumference is 2 pi. The total rotation around that curve, the edge length around the unit circle, is just a distance of 2 pi. Bringing it back to the previous page, that just means that if you were to measure out the entire distance all the way around, you would measure out 2 pi units, which is roughly 6.28 units. So let's go ahead and use that information to help us determine the terminal point on the unit circle, determined by t equals 5 pi over 4. So we have some unit circle, and I'm not going to be perfect this time about it. I'm just going to kind of chicken scratch a unit circle out. Okay. And we're running along the edge of this from the point 1, 0 in the positive direction, which means we're going counterclockwise. We start going into quadrant 1 and we go over. And the question is, how far is a length of 5 pi over 4? Well, if I told you the full rotation around was 2 pi, then half the rotation around should be pi. That should be half the distance around. So if we just ran around the edge of this circumference to this point, we would have gone pi. Now here's the trick in trig that you know from your prerequisite trig course, but you really want to write everything in terms of the denominators that you're talking about. So we're talking about the denominator of 4 here when we're talking 5 pi over 4. So I would rather call this 4 pi over 4, that halfway distance, than calling it pi. I would rather call it 4 pi over 4. So it gives me a reference that I'm almost to 5 pi over 4. I've gone 4 pi over 4. I just need to go a little bit more. But how much more is it really? Like, is it all the way up to here? Or is it to the halfway point? Well, the way you're going to determine that is to use just some logic. If this distance to that edge right there, let me highlight it. If this arc length all the way around to there is an arc length of pi, then the arc length of half of that to there is pi over 2. So I'm going to mark this as pi over 2. Thus, the arc length of even half of that, just to this point right there, would be an arc length of pi over 4. So I'm going to mark that as well. So right about here is an arc length of pi over 4. And that tells me, okay, if I'm going to rotate or I'm going to paint the edge of this unit circle a length of pi over 4, I go basically halfway through a quadrant. If I want to go pi over 2, I'll go all the way through a quadrant, right? If I want to paint a pi over 2 length, I'll go all the way through. If I want to paint 3 sets of pi over 4, well, here's one set of pi over 4, here's a second set of pi over 4, and here's a third set of pi over 4. If I want to paint 4 sets of pi over 4, that's pi, and 5 sets of pi over 4 would get me to there. So that's where my terminal point will land, right there in quadrant 3. Now I have to determine what is that terminal point. How can I find that? Well, something you should note, if that point is halfway, cutting halfway through the arc there, then it actually is on this line that cuts the world into half, cuts this circle into half, where half of this distance below is, because you can all agree that this is a 90-degree angle, half the angle below, or the angle below is 45 degrees and the angle above is 45 degrees. Well, that is a line with slope 1. This is a line having slope 1. It rises the same distance as it runs because it's a 45-degree angle. That's really going to help us. So let's go ahead and at least find this point. There's a beautiful symmetry about these 2 points. So let's go ahead and find this point right here. I happen to know that I have a 45-degree angle and another 45-degree, well, 90-degree angle up. So if you just see this little right triangle here, and I know the radius is 1 because we're on the unit circle. The big question is, what is this x value and what is that y value? Well, because they're opposite the same angles, 45 degrees on both of those angles, I could just call them both x's. They're both the same distance. And the Pythagorean theorem, which is basically the birthplace of trigonometry, tells us that x squared plus x squared, that was supposed to be an x, should therefore equal 1. Or in other words, 2x squared should equal 1. Or in other words, x squared is equal to 1/2. Or in other words, x is equal to plus or minus 1 over root 2. And if you're in my classes, I never require students to rationalize constant denominators like that, or denominators that are constant like that, because there's no point. There really is no point to do it in trigonometry. So I know the x value will either be plus or minus 1 over root 2 for this point. Well, since it's in quadrant 1, it's going to be a plus 1 over root 2. And the y value, the height here, is going to be the same as the x value because they're both 45-degree angles right here. So they're equal and opposite, or not equal and opposite, but they're equivalent lengths. So the y value is also going to be a 1 over root 2. Now, using that as a guide, since this point also exists down here, I'm just going to say, well, then the x value must be a negative 1 over root 2, and the y value must be a negative 1 over root 2. Let me write that in here. Negative 1 over root 2 and a negative 1 over root 2. And that is the terminal point for t equals 5 pi over 4. Now that we were lucky because it's a 45-degree angle that we're making here, and that's an easy one to work with. 45-degree angles are just lines like y equals x or y equals negative x. That's not terrible. But what happens if you have an angle that's not so nice? Well, that's what our next video is all about. What are the special triangles?
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.